everyone. In the last video we discussed about the stoichiometry, mole-mole analysis, mass-mass analysis, mass-volume analysis. In this video we will apply the concept mole-mole analysis to solve simple problems on stoichiometry. So let's take one example, that the decomposition of KClO3 into KCl and oxygen is given, and calculate the mass of KClO3 necessary to produce 960 gram of oxygen. So first we will write the balanced chemical equation for this. That 2 KClO3 will produce 2 KCl plus 3 oxygen G. So this is the balanced chemical reaction. Now we will relate the moles of KClO3 with the moles of oxygen, as the stoichiometric coefficient are in 2:3, which means that to produce 3 moles of oxygen, 2 moles of KClO3 is required to decompose. Yeah, we can say that to produce 3 moles of oxygen, 2 moles of KClO3 is required. Yeah, we can say that 2 moles of KClO3 on decomposition give 3 moles of oxygen. In this question, mass of KClO3 is required to determine. So we can say that to produce 3 moles of oxygen, 2 moles of KClO3 required to decompose. So for 1 mole we can say that 2/3 moles of KClO3 is required, and the amount of oxygen 960 gram is given. So we can convert this into moles. That should be equal to 960 divided by 32, that will be equal to 30. So we can calculate the amount of KClO3 which is required to produce 30 mole of oxygen. So for 30 mole of oxygen, the amount of the moles of KClO3 which is required to produce, that will be 20, right? So mass of KClO3 is required, so we can multiply the moles of KClO3 by molecular mass of KClO3, which is 122.5. On solving this, we will get 2440 gram. In the next question, in the B part, what mass of KCl is produced along with this quantity of oxygen? The quantity of oxygen which is produced is 960 gram, which is 30 mole, and the quantity of KClO3 which is produced is 20 mole. So the 2 moles of KClO3 from the stoichiometry, from the 2 moles of KClO3 produce 2 moles of KCl. So 20 moles of KClO3 will give 20 moles of KCl. So moles of KCl will be obtained as 20. So the mass of KCl, that will be equal to 20 into the molecular mass of KCl. On solving this, we will get 1480 gram. So this is the first question in which we apply the concept of mole-mole analysis. We can take one more example to understand the meaning of mole-mole analysis. It is given that number of moles of calcium chloride needed to react with excess of silver nitrate to produce 1430 gram of AgCl. So first we will write the balanced chemical equation of silver nitrate and calcium chloride. So CaCl2 aqueous plus 2 AgNO3 aqueous. This will give twice of AgCl plus CaNO3 whole twice. Now this is the balanced chemical equation. It is required to calculate the moles of calcium chloride, and the silver nitrate mass is given. So we can convert this 1430 gram of AgCl into moles. That moles of AgCl which is required to produce is 1430 divided by 143, which is the molecular mass of AgCl. This is 10 moles. So with respect to 10 moles of AgCl, it is required to calculate the amount of CaCl2. So very obvious from the stoichiometric relation is 1:2. So we can say that to produce 2 moles of AgCl, 1 mole of CaCl2 is required. So for 2 moles of AgCl, 1 mole of CaCl2 is required. So we can calculate for 10 moles of AgCl, 5 moles of CaCl2 will be required. So this is the answer, that 5 moles of CaCl2 is required. In the next question, we will apply the same concept, mole-mole analysis. It is given that in a rocket motor fueled with heptane C7H16, how many kg of liquid oxygen should be provided with each kg of heptane for its complete combustion. So first we will write the balanced chemical reaction of heptane, which will be C7H16 plus oxygen. This will produce CO2G plus H2OL. We can balance the reaction as 7 carbon and 8 to just 16 hydrogen. Now we can balance the oxygen, that 11 oxygen. So obviously from the stoichiometry we can say that for 1 mole of heptane, 11 moles of oxygen is required. So we can calculate the moles of heptane given. Moles of heptane given is 1000 by 100, that will be 10. So very obvious, for 1 mole of heptane, 11 moles of oxygen is required. So for 10 moles of heptane, the oxygen required will be 110 moles. On solving this, and the 110 moles can be converted into the gram of oxygen by multiplying this by 32, and it is required to calculate the mass of oxygen in kg. So we can divide the entire result with 1000 and we will get 3.52 kg of oxygen. We can take one more example to understand the mole-mole analysis, and which is application of mole concept, that when C2H4 is burnt in the air, carbon dioxide and water are formed. If on combustion of C2H4, 2 moles of CO2 is produced, then calculate the number of drops of water produced. Number of drops of water is produced along with this quantity of CO2. So definitely this is integer type question with respect to the IIT. If each drops contains 6.022 into 10 to the power 21 water molecules. So first we will write the balanced chemical reaction of combustion of ethylene, that C2H4G plus O2G. This will give 2 CO2G plus 2 H2OL. So the oxygen will be in the right hand side will be 6. So this will be the balanced chemical equation. Now for 1 mole of ethylene, 2 moles of CO2 is produced, and also 2 moles of water is produced. Now it is given that the number of water molecules which is present in each drops is 6.022 into 10 to the power 21 water molecules. So we can convert this number into number of moles. 6.022 into 10 to the power 21 divided by 6.022 into 10 to the power 23. Definitely this will give 10 to the power minus 2 moles. So this is the number of moles of water which is present in each drop of water. Now 2 moles of water is produced, so we can simply calculate the number of drops of water, that will be equal to 2 divided by 10 to the power minus 2. As we know that 10 to the power minus 2 is the number of moles of water which is present in each drop. On solving this, we will get 200 drops of water. So this is the simple problems. These are the simple problems on stoichiometry. In the next video, we will discuss about when the 2 or more than 2 reactants are involved, how we can solve the stoichiometric problem by using the limiting reagent. Thank you very much.